In this video, we discuss the topic of exponentiation. Exponentiation can be defined in the following way. Let a be an integer, and let n be a natural number. Then, the nth power of a is defined as the repeated multiplication of a with itself n times, which we also refer to as a to the nth. There are two special cases to point out here. The first is that if a is equal to 0, then the nth power of a is equal to 0 for all natural numbers n. The second is that a to the power of 0 is equal to 1 for every integer a. Some texts define 0 to the 0th power differently, but here we make the distinction that 0 to the 0 is equal to 1. This notation, a to the nth, is known as an exponential expression, and we call a the base and n the exponent. Exponential expressions have several nice properties that allow us to write complicated-looking expressions in simplified form. For the three properties below, we will assume that n and m are two arbitrary natural numbers, and a and b are two arbitrary integers. The first property states that when multiplying exponential expressions with the same base a, with potentially different exponents n and m, that we can rewrite this expression as the base a to the sum of the exponents n and m. Formally, a to the nth times a to the mth is equal to a to the n plus mth. The second property states that if we have an exponential expression a to the nth, and that quantity is raised to the mth power, that we can rewrite this expression as the base a raised to the product of the exponents n and m. Remember that multiplication of integers is commutative, so a to the n times m is equal to a to the m times n, which is equal to the exponential expression a to the m raised to the power n. The third property states that the product of two integers a and b raised to the nth power is equal to the product of those individual integers raised to the nth power. Formally, the quantity a times b raised to the nth power is equal to a to the nth times b to the nth. Here are some examples for you to try out on your own. Rewrite the following expressions using the definitions and properties we just discussed. Here are the solutions to each of these example problems. The final topic for this video is square roots. For any non-negative integer b, the square root of b is the non-negative number a such that a squared equals b, denoted like so. This strange-looking symbol we call the radical, and the non-negative integer b we call the radicand. For example, the square root of 100 is 10, since 10 squared equals 10 times 10, which equals 100. To get some more practice with square roots, try out these examples. In any example containing a variable, assume that that variable represents a non-negative integer. Here are our solutions to these example problems.